This comes out of section 7.2, derivatives of sine and cosine functions. So in this case, we're just asked to differentiate, and we're given y equals x cubed times cos x. So hopefully you'll see that as a product rule question. We're going to say the first function times the derivative of the second plus the second function times the derivative of the first. That's a decent answer right there, but you could at least factor out an x squared out of each of those two terms, and maybe write it in a nicer order. So I've got 3 cos x minus x sine x. Nothing else really factors out or simplifies that one, but there you go. First derivative in terms of x. This next example is implicit differentiation example. We've got sine x plus sine y equals 12, and we're asked to find the derivative y prime or dy by dx. So my first job is differentiate everything with respect to x. It gives me cosine x plus cosine y times y prime equals 0. So finding then my derivatives just means solving for y prime. I'm going to have y prime equals negative cos x over cos y. In previous units and parts of this course, we've been asked to find the second derivative from there. I'd like to take a second to try to find y prime, or the second derivative here, because that is a place where people have had some trouble. So I take the derivative of that with respect to y, or with respect to x, and we've got y prime equals the bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. So aside from dealing with some of the negative signs as I went there, just basically used the quotient rule. Now I do have this y prime term in there that would need to be replaced with what we just found up above. So I'd have cos y times sine x, and now this becomes minus cos x times sine y times, now the derivative that we just found was negative cos x over cos y, and all of that over top of cos squared y. Now that would at least get you an expression or equation that will allow you to find values for the second derivative. If somebody gave you x and y, you could figure it out. In terms of simplifying that, the best way that I think will take you the least number of steps is just multiply the top and the bottom by cosine y. Reason being is that you don't want to have a fraction within a fraction. So what do I have here? I'm going to have cos squared y sine x plus cos squared x sine y divided by cos cubed y. And so, nice, neater, tidier than what we had up above. Still useful. If they gave me x and y, I could figure out what the value of the second derivative is.